Okay, P.1. P.1, we're going to talk about interval notation today and um, exponent rules. You better be able to use the distributive property. You better know what inverses are. Better be able to do scientific notation. I'm not talking about it. Expect you to know that. I don't need to waste your time. So, interval notation. Hopefully you know this too. This is inequality notation. Interval notation would be that. We know when we graph this on a number line, the book uses parentheses instead of open circles and brackets instead of closed circles. It's an open circle facing that way. So is this. Open circles correspond with parentheses. Here's another one. Or equals are correspond with closed circles. If you're graphing on a number line, this is perfectly okay. You do not need to number everything. I usually like to have 0. It's not super important. You need more than one number. Okay, an interval notation, this one looks like that. Okay, if you're given the following sentence, you should be able to translate it to inequality and interval notation. You should be able to go back and forth. The real numbers between -4 and 0.5. And negative 0.5. So that is this. The real numbers between does not include either end. So 0 is here. So the interval notation is going to look like that. Why did I do a 0? The inequality notation, no or equal, is going to look like this. The real number is greater than or equal to 0. Greater than or equal, closed circle. Infinities are always parentheses. Infinities are negative infinities. Could also look like this is inequality notation. In this class, we will write nearly always in interval notation. Okay, we're going to convert between a couple. These are 3 different problems. Hopefully this is all very easy. This one, it's an interval, I convert to inequality. This says x is between -6 and 3. I'm including the -6. No or equal to. Yes, sometimes I write before I engage my brain. Some of you, I'm sure, do the same thing. It's fine as long as you fix it. This one, -2 to 3. Okay, the last thing in today's lesson is the exponent rules. Again, I fully expect that you know all of these. You've been learning these since Algebra 1, who knows how long ago that was, or Integrated 1, maybe even since middle school math. So, I guess I'll use the book's notation. These are on page 8 in our book. Yes, you're going to have to get used to the U's and V's in this class. Or you can see it, here's the other example they give. 3 plus 4 is 7. Usually these ones, I'm going to do a slightly different example. Usually I think of this, instead of subtracting, you get x to the negative 5 here. Usually I think of it as 4x's on top, 9 on bottom leaves me 5 on the bottom, 1 over x to the fifth. Anything to the 0 power is 1, including infinity. Maybe not including infinity. Depends on the context of that. There's what a negative exponent does. This is u times v to the m. Is u to the m, v to the m. I'm using u and v because that's the calculus way of doing it. Those are used a lot in calculus, and this is pre-calculus. Here I am multiplying the exponents. This I must square the 5. That's a common mistake, as people forget to apply the exponent to the number. Again, there's an example. And my last one, u over v to the m. Again, I apply them to both. Those are your exponent rules. Now we're going to use it for a few examples. So I took my numbers, 2 times 5, I multiplied them. Took my a's, I added the exponents, 1, which was not written, plus 2 is 3. 3 plus 5 is 8. One of the keys to exponent rules is doing one thing at a time. Here's a little trick on this one. I'm not going to apply the exponent, that's a 3. I'm not going to apply the exponent rules right away. I'm going to, in this case, I'm actually making them both positive. Sometimes that won't be the case. I will move them all to the top or the bottom. So all the u's to the top, all the v's to the bottom, or wherever, whatever makes most sense, wherever I think it's going to be positive. If I get it wrong, I'll just move it later. When you do exponent rules, you are not allowed to leave negative exponents in this class. In calculus, sometimes we put them into negative exponents because it makes things easier. You need to be able to do both. So my rule for this class is exponents need to be in a positive form in the right spot. Now I just add the exponents, u to the third over v to the fifth. Couple ways I can do this. I can just apply the rules right away, but I'm going to show you a different way. I don't love negative exponents, so I'm going to get rid of the negative. What does a negative do? I didn't get rid of the negative. It flips the exponent. So it flips the fraction. Usually you'll have v to the negative third and you'll call it 1 over v to the third. Well, 1 over v to the negative third is just v to the third. So in this case, the negative just flips the whole fraction from x squared over 2 to 2 over x squared. Now I can apply these to both. 2 times 3 is 6. 2 to the third is 8. 2 to the third does need to be simplified. If it's a reasonable number, you need to apply the exponent. If it is not a reasonable number, you do not have to apply the exponent. So if it's 7 to the 12th, I have no idea what that is. It's a huge number. Just leave it as 7 to the 12th. But if it's 7 cubed, that's 343, I believe. Let me double check that on the calculator. Yep, it's 343. That you do need to simplify. Okay, that's P